Hello, I am Teacher Marichu and welcome to our modular distance learning on Math Box of the Senior High School Pre-Calculus Quarter 1 Week 3B. The objective of this module is for the learner to determine the standard form of equation of an ellipse. For the generalization, we have standard equation of an ellipse with center at the origin, that is denoted as C00. The standard equations and properties of an ellipse with center at the origin and has a coordinate of C00 are given in the box. In all two cases below, here, let's describe these two cases. A is greater than B, and C is actually the square root of A squared minus B squared. The foci f sub 1 and f sub 2 are C units away from the center. The vertices B1, B2 are A units away from the center. And the major axis has a length of 2A. So we have the two vertices here, and that determines the distance A. And the length, this is the minor axis, the endpoints of the two vertices, that is 2A. For the center, it's here, and F1 or focus 1 of the ellipse and F2 is collinear with the center and the two vertices, as explained in the first video. The co-vertices W sub 1 and W sub 2 are B units away from the center, and the endpoints of W1, W2 is the co-vertices. The endpoints of the co-vertices determines the minor axis, and the distance of the minor axis or the length is 2B. In standard equation, if the x part of the ellipse has a bigger denominator, the ellipse is horizontal, like in this case. And if the y part has the bigger part or has a bigger value, then the ellipse is a vertical ellipse. Okay. So this one, this is the equation, the equation of an ellipse in standard form. In this case, A is bigger than B. It is a horizontal ellipse. And if A is greater than B and A is on the y part, then we have a vertical ellipse. And further, the major axis is horizontal. That means if it is a horizontal ellipse, the major axis is also horizontal. And so the minor axis is vertical. Then, if it is a vertical ellipse, the major axis is also vertical, and the minor axis is a horizontal axis. The minor axis lies in, or is lying. An important relationship between A, B, and C is that C squared equals A squared minus B squared. This is true because of the fact that the distance of the first side, say in this case, we have D1 and D2. If we sum that up, it's 2A, as discussed in the first video. So for example 1, kindly explore it with all your heart so that you understand the concept of an ellipse in standard form. Here y we have horizontal ellipse. Let's go over with the equation. It says here x squared over 169 plus y squared over 25 equals 1. And take note, 169 is bigger than 25. So this will be our A, and our B is, A squared is 169 and B squared is 25, giving us A equals 13 and B equals 5 respectively. And when A and B are already known, we can find the value of C. So this is all for the horizontal ellipse. The same analysis will be done later for the vertical ellipse. Let's try to consider exercise 1, number 1. We are instructed to give the coordinates of the center, the foci, the vertices, and the co-vertices of the ellipse with the given equation. Let's start with number 1. We have x squared over 25 plus y squared over 16 equals 1. Solution. We identify here 25 and 16. Since 25 is bigger than 16, this is a squared. So a squared equals 25, a becomes 5. Then this is b squared. B squared is 16, b is 4. And from the equation c squared equals a squared minus b squared, Pythagorean theorem applies here. Then we have c squared equals, plugging on the values of a squared and b squared, c squared is 9, and finally c is 3. So we have the center, of course, is at the origin. The foci lies on the value for c. So f1 is negative c0, in this case c is 3. So we have negative 3 and 0 and 3, 0 for the coordinates of the foci. For the vertices, we have b1 is negative a0 and b2 is a0. In this case, since a is 5, so we have the coordinates of the vertices as negative 5, 0 and 5, 0. The co-vertices, we have w's of 1, coordinates of 0, negative b, and 0, positive b. So in the given, we have 0, negative 4, and 0, 4. This concludes solution for number 1. Moving on to number 2, we have x squared over 169 plus y squared over 144 equals 1. Solution. Identifying a squared. The bigger denominator is a squared, so it's on the x part still. So we have a squared equals 169, giving us a equals 13. B squared equals 144 will give us b equals 12. Solving for c squared, we have a squared minus b squared. C squared equals 25. Solving for c, c equals 5. Having done this, the center is at the origin. Foci, or the focus, is negative 5, 0, and another focus at 5, 0. Vertices, vertex 1 is negative 13, 0, and 13, 0. And co-vertices, we have 0, negative 12, and 0, 12. Moving on to example 2. Example 2 discusses on the standard equation for vertical ellipse. The example 2 highlights vertical ellipse, how to detect that a given equation is an equation of a vertical ellipse. While it says in the generalization earlier that the y part is bigger then the x part. In this case, y is 100, or this is the a squared part, and this is the b squared, 36. Okay. So further solution of example 2. So here are the tips for vertical ellipse. You have it in your module. And this is the solution for the given problem above. And let's go to exercise number 2. Exercise number 2 is all about vertical ellipse. Again, we are instructed to give the coordinates of the center, the foci, the vertices, and the co-vertices. Let's start with number 1. We have x squared over 9 plus y squared over 25 equals 1. Solution. We have to identify between 9 and 25 which is which. So the greater is a squared. So a squared equals 25. A is 5. B squared is 9. B is 3. Solving for c squared equals a squared minus b squared. C squared equals 16, giving us c equals 4. And I have here, actually I compressed the solution into the two ellipses. Let's consider first number 1. Well, to recall, the components of vertical ellipse in capsulized form: center with the origin, foci 0 plus minus a, coordinates, vertices, coordinates 0 plus minus a, and co-vertices plus minus b, 0. For number 1, since we have already c equals 4, then the foci lies at the coordinates of the points 0, 4, and 0, negative 4. The vertices lies on the coordinates 0, 5, and 0, negative 5. Co-vertices lies on the coordinates positive 3, 0, and another coordinate negative 3, 0. That concludes ellipse number 1, vertical ellipse. For number 2, we have here x squared over 25 plus y squared over 144 equals 1. Solution. We have to determine again which is bigger, 25 or 144. Obviously, 144, that is a squared. A is 12. And what is left is b squared equals 25. B is 5. C squared equals a squared minus b squared. So that's 144 minus 25. That's 119 for c squared, giving us c equals 1 square root of 119, or approximately equal to 10.91. So for number 2, center at 0, 0. Focus at the coordinates or foci at the coordinates 0, positive 10.91, and 0, negative 10.91. For the vertices lies at 0, positive 12, and 0, negative 12. Co-vertices lies at positive or negative 5, 0. That concludes exercise number 2. And we move on to example 3. We have a different form of equation now. In this case, we have a quadratic equation without involving fraction, okay, but still an equation of an ellipse. I leave it to you to explore example 3. It's a little bit long process here. So I'm just showing you here. Here are the components of a vertical ellipse and the parts of the ellipse, the center, the foci, and the vertices and the co-vertices of the given ellipse in example 3. Moving on to exercise number 3. We have to give the coordinates of the given ellipse with regards to its center, foci, vertices, and co-vertices. Let's start with number 1. We have 4x squared plus 13y squared equals 52. Now, we have to convert this equation into the standard form of an equation of an ellipse with the right-hand side being equal to 1. So, we have to divide both sides of the equation by 52 in order for this right-hand side to be 1. Let's see in the solution. Okay. Dividing both sides of the equation by 52 will give us the ellipse in standard form x squared over 13 plus y squared over 4 equals 1. And in this case, how did we know that it's a horizontal ellipse? Meaning the major axis is horizontal and it's actually the x-axis, because the ellipse in this case centers at the origin. So we have here how to detect it's horizontal. 13 is bigger than 4 and 13 is on the x part. So a squared equals 13, giving us a equals square root of 13. B squared is 4, giving us b equals 2. Solving for c, let's start with c squared equals a squared minus b squared. Then we have c squared equals 9. C is 3. We have here the note. Recall the parts and coordinates of horizontal ellipse in standard form. We have here center origin, the foci plus or minus C0, vertices plus minus A0, and co-vertices, coordinates 0 plus or minus B. Now in this case, since we have A, B, C values already found, we just have to plug in. Focus 1 is negative 3, 0 in terms of their coordinates, and the coordinates of focus 2 is positive 3, 0. The coordinate of vertex 1 is negative square root of 13, 0, and another vertex positive 13, 0. Co-vertex 0, positive 2, another one is 0, negative 2. So this is for number 1. Moving on to exercise 3, number 2. The equation is 16x squared plus 15y squared equals 240. Now transforming it in a standard form, divide both sides by 240. Then we end up with x squared over 15 plus y squared over 16 equals 1. And this is a vertical ellipse. Why? Between 15 and 16, 16 is greater and 16 is on the y part. So this is a squared, giving us a equals 4. And the b squared is 15, giving us b equals square root of 15. And solving for c, we have c equals 1. Okay. And recall the parts of the vertical ellipse. This is a vertical ellipse. Okay, so centers at the origin. The foci, we have coordinates of the foci 0, positive 1, because c is 1, and 0, negative 1. The coordinates of the vertices, 0, positive 4, we have here a equals 4 because a is, the y-axis is the major axis. So we have the vertex. The endpoints of the minor axis are 0, 4, and 0, negative 4. The endpoints of the major axis. Now, co-vertices. The co-vertices are the endpoints of the minor axis. And in this case, the minor axis is the x-axis. And with coordinates positive square root of 15, 0, and negative square root of 15, 0. Moving on to another example in the module, we have example 4. Find the equation in standard form of the ellipse whose foci are given and the sum of the distances. Those are the given. We have focus 1 and focus 2, and then the sum of the distance of any point on the ellipse going to the 2 focus. Okay, and it's given to be 20. So this is the process for you to explore. I'm just showing it for you to get familiar with and for you to study this, because I will be discussing the solution for the problem or the exercises related to this example. Here. So I have to proceed with exercises 4. Okay, let me show. Focus this. Okay, here. We have to find an equation in standard form of the ellipse whose foci are given with coordinates 0, negative 3, and 0, 3, such that for any point on the ellipse, the sum of its distances from the foci is 10. Okay. Solution. Let me have it here. For number 1, we're given coordinates 0, negative 3, and 0, 3. How do we know that it's a vertical ellipse? Well, because of the coordinates. The coordinates 0 for x, and it is along the y-axis, so meaning vertical ellipse. So that means c is 3, giving us c squared equals 9. Now, we are given also that the distance between any point on an ellipse, the sum of the distance of the segment from any point of an ellipse to its foci is 2a, and 2a here is given to be 10. We have to solve for a. 2a equals 10, giving us a equals 5, so a squared is 25. We have now the value for a squared and c squared. We have to find the value for b squared. From the equation c squared equals a squared minus b squared, we have b squared. Isolating b squared will give us a squared minus c squared, and b squared is 16, giving us b equals 4. Since this is a vertical ellipse, a squared must be on the y part. Okay, so hence the required equation of an ellipse in standard form, we have x squared over b squared plus y squared over a squared equals 1. Then plugging in the value for b squared is 16 on the x part. It's smaller than the a squared on the y part, which is 25. This is the required equation of the ellipse. Moving on to number 2, let me read the problem. Find the equation in standard form of the ellipse given the foci negative 12, 0, and 12, 0, such that for any point on the ellipse, the sum of its distances from the foci is 26. With the same analysis as in number 1, we have here, we start with the coordinates of the foci, plus or minus 12, 0. Since the foci falls along the x-axis, so it is where the major axis lies. So we have a horizontal ellipse. And we know for a fact that c equals 12, giving us c squared equals 144. And it's given also that the distance from any point of the ellipse to its two foci is 26, the sum of its distance. So then we equate 2a equals 26. A is 13, a squared is 169, or 13 squared. We found already a squared and c squared. B squared is actually a squared minus c squared, giving us 25. Actually, we don't need b in this equation. But anyway, since this is a horizontal ellipse based on the given foci, so we expect that a is bigger or greater than b. So in this case, a squared, it's a, or a squared. A squared is 169 on the x part, and what is left is b squared is on the y part. So the required ellipse is x squared over 169 plus y squared over 25 equals 1. This is an equation of an ellipse, of a horizontal ellipse in standard form. Again, this is Teacher Marichu saying, always stay happy and healthy. God bless.